Okay, so in these problems, we're trying to see if there is a direct variation or an inverse variation or neither kind of variation. All right, and then we're going to write the equation to model whatever it is we see. So I'm going to look at, see x is getting bigger, right, and then y is getting smaller. So if I want to check for a direct variation, I'm going to divide. I'm going to take y divided by x. So it would be 10 divided by 2, 5 divided by 4, 4 divided by 5, and 1 divided by 20. All right, I would do all these y's divided by x and see if that is the same number every time. Well, this first one, I know 10 divided by 2 is 5. Well, this is definitely, 5 divided by 4 is definitely not 5. All right, so it's not a direct variation. All right, so x is getting bigger and y is getting smaller. So it could be inverse variation. All right, so but that would mean that x times y is going to be a constant. All right, so when I multiply 2 times 10, that's going to equal 5 times 4, which would equal 4 times 5, which would equal 20 times 1. And those all equal 20, right? So yes, it is an inverse variation. All right, that is an inverse variation. The equation to model that, remember, would be y equals, and you put your constant, which would be 20 over x. All right, that is my equation to model this inverse relationship. With an inverse, you have x in the denominator and y on top. All right, so as x gets bigger, y gets smaller. All right, so look at number 2. I'm checking to see, again, if that is inverse or direct. So x is getting bigger, and y is also getting bigger. All right, so it could be a direct. All right, and again, if I want to check for that, I'm going to do y divided by x. So that would be 2 divided by 1, 8 divided by 3, 20 divided by 7, 29 divided by 10. And those are different, right? Those are definitely different. X is getting bigger, y is getting bigger, but they are not the same. All right, so that would be not a direct variation. Okay. And it can't be inverse because for inverse, one is going up and one is going down. These are both going up. Okay. So look at number 3. I have x is getting bigger, right? And y is getting bigger. Okay, so it could be a direct variation. All right, it could be a direct variation, which means y divided by x is going to be some constant. So I will check that out. I'm going to take 6 divided by 1, 12 divided by 2, 30 divided by 5, 42 divided by 7, and they're all equal to 6. So that is a direct variation, all right? And my equation would be y equals my constant, which is 6 times x. All right, it kind of looks like y equals mx plus b, where b is always 0, all right, because it goes through the origin. So looking at number 4, the x's are getting bigger and the y's are getting bigger, all right, so that could be a direct variation. I'm going to check out y divided by x. All right, direct, you divide. So I'll take 25 divided by 0.2 and 62.5 divided by 0.5 and 250 divided by 2 and 375 divided by 3 and see what those are. So 25 divided by 0.2 I will check on my calculator. 25 divided by 0.2. So 25 divided by 0.2. That's 125. 62.5 divided by 0.5 is also 125, and 250 divided by 2 is also 125, and 375 divided by 3 is also 125. So they all equal 125. So that is my constant of variation. If I want to write my equation, it would be y equals 125x. All right, because it's a direct variation. All right, and if I'm looking at 5 to see if that is a direct variation, I say, oh, well, this is getting bigger, right? And these are getting smaller. The x's are getting, so it could be either one, all right? It could be either one. So let me see if it's a direct variation. I would divide. Y divided by x is going to equal some constant. So 31 divided by 1/10, 7 divided by 1/2, 3 divided by 3/2, and 5/2 divided by 2. Okay, I have to check those all out. Well, as soon as 2 don't work, then I don't have to go any further. So 31 divided by 1/10. So 31 divided by 1/10. Oh, shoot. 31 divided by alpha y equals, enter, 1/10. All right, it's 310. And then I had 1/2, or no, 7 divided by 1/2. So 7 divided by alpha y equals 1/2 is 14. So I'm done. I know it's not a direct variation. All right? So not a direct variation because these were not equal. Oh, I should use this. Not, that means not equal to. Okay? So they're all not equal. So now, but it could be inverse, right? If I want to check for an inverse variation, that means x times y is going to be a constant. So I would take 1/10, 1/10 times 31, see if that's equal to 1/2 times 7, see if that's equal to 3/2 times 3, see if that's equal to 2 times 5/2. Okay. So 1/10 times 31. So alpha y equals 1/10 times 31. Oh goodness, forgot the arrow over. 1/10. Oh, so 1/10. Arrow over times 31, and enter. All right, so 31/10, all right. And then 1/2 times 7. So let me make that 31/10 into, make it into a decimal. Oh, okay. All right, well 31, actually, I'll just use my head. All right, if this is 31/10, that's 3.1. Okay, so now let's do 1/2 times 7. So 1/2, 1/2, an arrow over, times 7, and I get 7/2, which let's see if I can do this time, which is, I'm going to make that into a decimal. So I just hit enter, so 3.5. So math, enter. So this is 3.5. And they are not equal, right? That if you have an equal sign with a slash through it, that means not equal. So I know that it is not inversely inverse variation. All right, and then you would do the same thing to check for 6. So go ahead and check it out, and we will come by and see how you did.